Hello and welcome. Thank you for joining us. Today, we will be discussing how to provide work from home contact center agents with secure access at scale with Amazon end user computing. My name is Sam Goad, and I am a senior specialized solution architect for end user computing here at AWS. I will also be joined by John Farinelli, a senior cloud solutions architect for Maximus Cloud Center of Excellence, as well as Jason Winters, principal architect for Maximus Technology or Architecture. Today's agenda, we will talk about some of the significant challenges faced by contact center customers when forced to adapt to a work from home workforce, whether environmentally driven or by the progressing nature of how the workforce is continuing to evolve to a work from anywhere mentality. We will learn how AWS end user computing services help address this need by leveraging the agility and security of the cloud. We also will hear from a customer, Maximus, who will share real world examples of how they leverage these services to meet the rapid need to move their workforce home due to the 2020 pandemic. Finally, we will dive deep into automation and scaling of these services, as well as recommended best practices on architecting contact center agents connecting to AWS end user computing services. At AWS, we have been doing end user computing for over 7 years. During that time, we have worked with many contact center customers and have come to understand the critical necessity that this business function provides. Contact centers are at the front lines of your customer's experience and satisfaction, whether that is providing internal support services such as IT support, customer care by assisting with inquiries, sales by assisting with purchases, or marketing through surveys or franchise support for the hospitality industry. That's just to name a few. We have several services that help address contact center customers' needs, such as Amazon Pinpoint and Amazon Lex. But in this talk, we will focus primarily on our end user computing services. This brings us to the unique business challenges. Customers tell us that as their customer base is often global and operate 24/7, they need to be offer services that are reliable. The infrastructure supporting this global dispersed 24/7 workforce needs to be highly available, not only by being resilient to support crucial uptime, but also placing infrastructure closest to their agents to ensure lowest latency to apps and data they need to optimize their productivity and ensure the best quality agent engagement to their customers. Traffic patterns and call volumes can fluctuate due to seasonal demands or everyday peak hours of operation. Having a solution that is agile is paramount for customers to scale up and down based on demand and offer flexibility to support a traditional office centric workforce, or when presented with an external paradigm or an ever evolving work from home anywhere demanding workforce. Agent productivity is important whether they are communicating via line phone call, chat, or social media. Part of this success is having access to the correct end user computing environment that has been tested and validated to meet core requirements. Agent productivity can also be aligned with customer satisfaction. Security and compliance is at the forefront of concern for contact center customers. As data is becoming more complex and integrated with third party systems and analytics, contact center customers need to provide secure access to that data for their agents while safeguarding data from malicious or accidental leakage from not just their core systems, but from their endpoints. An example could be a employee who has lost or had a laptop stolen, or their endpoint is compromised from malicious malware. Finally, cost optimization. Customers are always seeking to reduce IT expenditure, and that can be achieved by only paying for what you need. There are four core benefits as to why our contact center customers choose us to deliver secure access to their end users. First, we increase reliability. Running VDI on prem is hard. When I talk to customers about uptime for their systems they have built over the years, and I tell them that we have a 99.9% uptime SLA, they understand the power of the cloud to improve end user productivity. And now, other companies are starting to move to the cloud as well. And we're excited that others see the future of virtualization is in the cloud. But we've been at this since 2014, and there is just no compression algorithm for experience. Second, we help you increase agility. Organizations need to scale up and scale back access at a moment's notice, and they need to move their end user computing power to anywhere on the globe overnight. Our services allow you to roll out Windows and Linux desktops and apps anywhere in the world in minutes, and you can unroll them just as quickly. End user computing power when and where you need it. No international data center contracts required. Third, we help customers increase security. At AWS, everything we do starts with security, and our EUC services are built on the AWS cloud. The AWS cloud has over 200 security certifications and is built for the needs of our most security-focused customers. With Amazon WorkSpaces and Amazon AppStream 2.0, all communication to the endpoint device is encrypted over secure protocols, including PCI-IP, NICE DCV, and WorkSpaces streaming protocol. No user data is stored on the local device, reducing opportunity for loss. Fourth, we help save you money. Because we run in the cloud at scale, we can keep our infrastructure costs low and pass them on to you. We have a range of compute instances and bundles that help you find the right level of performance for your users at the right price. And of course, we are as a pay-as-you-go. No need to worry about buying servers or licensing. Just pay for what you use. Don't pay for what you don't use and get on with your business. Underlying all of this, we are a fully managed service. As you can see, customers are enabling agents to work from anywhere using AWS end user computing services. Our customers often ask several questions before building a contact center solution on AWS end user computing services. Some of these questions are: how do I rapidly enable my agents to work from home effectively? How do I quickly onboard new agents to meet unprecedented spikes in call volume? How do I maintain government regulations and security best practices from a remote environment? Also, where and how will the agents be connected? With those questions being asked, I would like to bring in Jason and John from Maximus and to let them tell you their story.
Thank you, Sam. Hello, everyone. My name is Jason Winters, and I am a principal architect here at Maximus. In 2018, Maximus IT adopted a cloud-first strategy with a goal to move all of our systems to the cloud. We chose AWS as our primary cloud provider. Much of our business revolves around call centers for local, state, and federal agencies. We had approximately 3,000 users using our on-prem based and locally managed VMware Horizon VDI system. Moving our users from the local VMware VDI system to the cloud meant cost savings by not having to renew VMware licenses, but also saves us other operational cost savings by sunsetting the internal VMware infrastructure. In early 2020, we were given a deadline of January 2021 to completely sunset VMware VDI and get all users moved to a new platform. We were in the process of investigating AWS WorkSpaces, as it was the most logical next step, as we were heavily investing in AWS as our cloud provider. We then made a goal to move 3,000 users over 6 months' time, ending in October, November of 2020. Then, of course, we all know what happened next. The COVID-19 pandemic hits. Offices are closing, users are forced to work from home. We had to think fast and devise a strategy that would allow us to accelerate our goal exponentially. We had to get people back to work fast. Due to our efforts, we were able to move over 16,000 people to AWS WorkSpaces in less than 3 months, cutting 3 months off of our original goal and moving more than 5 times as many users. So just how did we do that? At first, we were interested in using BYOL images so that we could maintain a single image for VDI, laptop, desktops, and also take advantage of less expensive licensing. However, when we needed to scale the BYOL workspaces to large numbers, we found that there were significant delays in approvals and a wait time while AWS could build new infrastructure for us, due to the fact that BYOL workspaces live on their own dedicated hardware. We were limited in our ability to scale, and because of this, we decided to go with the standard AWS workspace image and customize this image to bring it to the Maximus standard. Using the standard image allowed us to scale at unprecedented levels, adding as many workspaces as we needed in a short amount of time. Our new image process works like this. New images are first updated with the latest patches from Microsoft. Then we pre-install with common tools such as Adobe Acrobat Reader, Firefox, and Chrome, as well as install software patching and distribution agents such as BigFix and SCCM. We also employ an automated Python script that runs on a management server to move workspaces to the proper OU in Active Directory based on project-specific tags that after they've been deployed. We limit the size of our directories to 1,000 users or a /22 subnet. This number was chosen based upon a few different factors. The most important factor was having the ability to make changes or do maintenance in smaller chunks instead of a big bang where we would have affected all users at once. CloudFormation templates were built to create VPCs and directories that were required, as well as all of the supporting infrastructure like Route 53 resolvers, transit gateway attachments, and security groups. These, tied in with other scripted CLI commands to finish up the final details of the workspace's directory, like directory settings and MFA configuration, made deployment of new directories fast and consistent. An entire new directory ready to deploy new workspaces can be created in a matter of minutes. Internet egress is directed to a single egress VPC per region using Gateway Load Balancer to place redundant firewalls in between the users and the internet. Force point agents do URL filtering direct on the workspaces. All directories are set up for secure access using multi-factor authentication. For our call center users, we use a mix of different soft phones. Currently, we are standardizing on the Genesis platform, a cloud-based SaaS solution. Cisco Jabber and Avaya 1X are tied back to PBX systems in our on-prem data centers. We utilize Verizon Direct Connects across our MPLS network to get connectivity from on-prem to AWS. One side note about Avaya 1X and using the AWS standard image. AWS standard Windows 10 image is actually Windows Server, running the Windows 10 desktop experience. When we installed 1X on the standard image first, it gave us an error saying that it was not supported on Windows Server. This gave us some concern and contacted Avaya for assistance. They basically told us that it didn't work on Windows Server, so we had to improvise. We figured out a registry key that Avaya was checking to tell what OS it was being used, and we used a script to change that key in the image. So it told 1X it was running on Windows 10. Funny enough, this worked, and we've had zero issues with Avaya 1X clients since making that registry change. We install all soft phones in the workspace and not on the host machine. Today, we're supporting around 40,000 workspaces in 3 regions and continue to win new contracts to build new call centers. Our cloud engineering team supports a continuous development and improvement lifecycle for our products. As you can see in the stats on the right, we have approximately 40,031 workspaces, 3 regions, 90 directories, 21 different bundles, 14 different images, and 551 Active Directory security groups. So how do we manage all this growth? I'm now going to turn it over to John Farinelli, our Senior Cloud Solutions Architect with our Cloud Center of Excellence team, to talk about our advancements in large-scale workspaces deployment and management. John?
Thanks, Jason. At Maximus, we knew we needed an automated solution to help us manage the scale of our workspaces footprint. No one could have predicted just how large our workspaces fleet was going to grow, but we knew automation would be key in helping us deliver a consistent and expedient way for our customers. In a contact center environment, we understand that it is not uncommon for projects to experience high employee turnover. We want to remove unused workspaces as quickly as possible to save on costs, but we also want to have workspaces deployed practically in sync with new employee onboarding so that resources could be available to them for training on day one. Some contracts we win also have a very short runway, so we needed to be able to deploy hundreds, if not thousands of workspaces at a moment's notice. As we started thinking about this, we considered the different deployment patterns we might have. We started out building workspaces for our IT teams before rolling them out to the company, and we knew we wanted to restrict those workspaces to specific target directories. That would allow us to easily leverage legacy IP-based security controls on other systems and ensure elevated access is only coming from known internal IP ranges or via expected security stacks. Another pattern might address users impacted by international regulations, such as GDPR, and understanding they may be working with data that must remain in specific regions. And finally, you of course need your pattern for standard user deployments. We wanted our selected automation solution to be able to deploy workspaces according to these patterns in a way that does not also exponentially scale the management and administrative overhead for our provisioning team. As we started on our workspaces journey, we engaged a third party to provide us with these automation tools. Amazon has partnered with several companies that provide Amazon Workspaces automation and management. However, a few issues quickly emerged as we became one of the largest consumers of Workspaces that this partner had worked with at the time. The first issue was the provisioning of Workspaces across multiple directories and AWS accounts. We leverage Active Directory users and group membership to control which employees are provisioned Workspaces for different projects. Within our partner's management system, you would configure the launch parameters for a workspace, select the appropriate AD group for provisioning, and everyone in that group would get a workspace. Unfortunately, during this configuration, you were limited to only a single build directory. This made the management of available IP addresses within these directories very difficult to manage, as we had to closely monitor the AD group sizes and break apart AD groups so they could provision in different directories as required. This was incredibly time-consuming, error-prone, and inefficient. Another issue that quickly emerged was a limitation of 500 grants per AWS KMS key, which we used to encrypt the storage for our workspaces. The 500 grant limit was the limit at the time, but AWS has since increased that to 50,000 per key. Our partner had no system to monitor the usage of these KMS key grants, and workspace provisioning would fail if the limit was reached. We had to manage these keys manually on our side, which further complicated the administration. Finally, as we grew, we started experiencing issues with AWS API throttling in our Workspaces account. Looking at the CloudTrail data our partner was generating, we knew we could do better. Because of these issues and more, we ultimately decided to craft our own automation platform and management solution. By building something in-house, we were able to ensure that it fit our use case perfectly, and were able to iterate on our solution much faster than any external partner who had other customers to contend with. We consulted with our AWS TAMs, and with their encouragement, we charged full speed ahead. There are several AWS blog posts around automating the provisioning of workspaces and the creation of a self-service portal that are available for reference, which help jumpstart the process. Here is how we solve the aforementioned issues. First, our automation platform does not reference specific directories to provision workspaces. Instead, we leverage tags on our workspace directories to group them together based on their build pattern. Directories that align on security posture, access needs, build type, etc., would all be tagged with the same category identifier, and those tags would then be referenced in our build parameters. For example, the build details for IT employee AD groups references that those workspaces must be built in IT-specific directories. If we require more directories down the line, we just build the directory with our CFTs, tag it with the appropriate directory category, and it's immediately available for workspaces for those groups. Second, we completely abstracted the KMS key usage for our build parameters. Instead, we have a separate automation solution that tracks a pool of KMS keys, and their usage can inform our Workspaces provisioning automation which key has the least uses so far. As keys are used up, we can create more on demand and never worry about reaching the 500 grants per KMS key limit that existed back then. Finally, we needed to tackle the API throttling issues. In hindsight, we should have investigated spreading our workspaces over multiple accounts sooner. Since we had already developed the deployment patterns and tag-based identification of directories, this would have been trivial. However, even now, we are still able to keep this under control as we surpass 20,000 workspaces within a single region and AWS account. We do this in primarily two ways via our custom-built front end we call CloudFactory. One, we maintain an up-to-date database of our workspaces fleet within an AWS-managed Elasticsearch cluster. As long as we keep that data current, we can query it as much as we'd like instead of making describe calls against the AWS API. We leverage a combination of CloudTrail event tracking, targeted workspace describe calls for those in a changing state, and sanity check crawling of the environment to ensure it never falls behind. Secondly, for mutable actions, we make calls against our own API first, and our system is aware of all AWS Workspaces API calls against the system. It makes a best effort attempt to batch up similar API calls and handles the retry functionality for the user. Because of these abstraction tools that we have built, we will be able to approach a multi-account Workspaces fleet, and the perception of administration for those workspaces from our provisioning team will not change at all. This is a flow diagram that represents most of the bits and pieces relevant to our Workspaces provisioning process. Just to call out a few key components, marked by the pink 1, we have a DynamoDB table, which stores the Workspaces configuration parameters for each AD group. Each item in this table identifies an AD group, as well as what directory it should deploy to, and other relevant data like compute type, drive size, and project and billing tags, etc. Marked with the 2 is a Lambda function that's really at the heart of our provisioning process. This Lambda function is fed the AD group configurations, and it compares the users that are part of that AD group with who currently has a workspace. Information on that workspace's fleet is stored in Dynamo, so we don't have to query the workspace's API constantly. When the Lambda finds a discrepancy, it can create and terminate jobs in Dynamo to be picked up by the step function depicted below. That step function is marked with the number 3. By the time the job gets to this step function, all of the decisions have been made. Earlier, Lambda selected what directory a workspace should go in, which key to encrypt with, etc. All this step function has to do is fire off the create workspaces API call and monitor for that workspace to become available. Once complete, welcome email is sent to the user with the registration code and all other information necessary for them to access their newly provisioned workspace. Not depicted in this diagram are some follow-up steps that take place depending on the project that the workspace is a part of. Jason mentioned this previously, but our workspaces are all tagged with a project name. And after the workspace is built, we have an additional automation script that fires to move the computer object in AD to the appropriate OU. And this allows for the application deployment specific to that project to occur. I hope hearing about the approach we took at Maximus and our story is helpful to you. Sam, back to you.
Thank you, John and Jason, for sharing your journey with WorkSpaces and sharing your CloudFactory solution. Now let's dive deep and understand the components needed to provide scaling and security among the agility and security pillars. Let's look at CloudFormation. By utilizing automation tools such as AWS CloudFormation, which is a service that helps you model and set up your Amazon Web Services resources so that you can spend less time managing those resources and more time focusing on your applications that run in AWS. Customers can use CloudFormation to commission and decommission environments, and this is very useful if you have a number of accounts that you want to build out in a repeatable fashion. A quick call out, not all options are available in CloudFormation. For example, you can create a directory, but you cannot enable a directory for workspaces. As Maximus has showcased, companies can leverage a wide array of native AWS tools to build secure and scalable solutions. CloudFormation is not the only tool. AWS EUC services also integrate with AWS native and existing enterprise tools. Administrators can leverage existing Microsoft Active Directory policies to easily integrate into their existing environment. This also allows companies to leverage already set in place security practices and procedures while allowing the flexibility to build their own custom solution, such as the CloudFactory implementation by Maximus. Companies can also utilize the service catalog to provision EUC resources and integrate with their service management tools like ServiceNow. Customers can utilize the WorkSpaces API to automate and script many actions. Here are a few examples. You can create, modify, reboot, start, stop, and even tag workspaces. In the following code, we are using the AWS tools for PowerShell to run a script to capture the workspace ID, last state check, last user active, directory, and compute type. And here is an example output of that command. All Amazon Workspaces public APIs are fully supported on AWS Private Link. This increases the security of data shared with cloud-based applications by reducing the exposure of data to the public internet. Workspaces API traffic can be secured inside a virtual private cloud when administrating your Amazon Workspaces fleet. Using Private Link for public APIs, you can choose to restrict API traffic to stay within your Amazon VPC, which can be isolated from the public internet. Using Private Link, the Workspaces public APIs also enables you to securely expose REST APIs to resources only within your VPC or to those connected to your data centers via AWS Direct Connect. You can also restrict access to selected Amazon VPCs and VPC endpoints, as well as enable cross-account access using resource-specific policies. With the AppStream 2.0 service, you can also utilize API calls to automate and build custom tools and scripts. Some examples of common items are creating stacks and fleets, deploying and updating image builders, expiring user sessions, and also tagging resources. From the snippet of a sample code, you can see that you can leverage the CLI to call AppStream APIs and set up a scheduled-based scaling policy to set capacity every day at 9 a.m. Another callout is that you can also leverage AWS Private Link to make secure API calls within the VPC instead of over the public internet. Amazon Virtual Apps and Desktops as a Service helps security teams protect their sensitive and valuable business and customer data. And it's coupled with strong authentication integrations and secure access measures. Amazon's secure remoting protocols add an additional layer of data protection for organizations. All app data is processed on AWS, and only encrypted display, keyboard, and mouse data traverses the remoting protocols. No app data touches the endpoint, which also helps with meeting local data residency requirements. For more data control, built-in data protection policy controls are available that can restrict users from copy-paste and file download actions on company data, as well as the ability to restrict printer redirection. Also, an administrator can set session timeouts to automatically end rogue or unused sessions. Enabling authentication such as device certificates, multi-factor authentication, and integration with popular identity providers ensures strong authentication measures are enforced. And with AppStream 2.0, you can use an interface VPC endpoint in your Amazon Web Services account to restrict all network traffic between your VPC and AppStream 2.0 to the Amazon network, including the streaming traffic. A quick call out. WorkSpaces does not support VPC endpoints to restrict traffic and stream from those endpoints. With WorkSpaces, you can leverage IP access control groups to control which IP addresses your workspaces can be accessed from. Here, we have an EUC contact center recommended architecture. As you can see, streaming traffic is initiated from the end user's device, which is traveling through the internet via end-to-end encrypted streaming protocols, P/IP, WSP, and DCP. This traffic ingresses the public AWS endpoints, and after auth, connects via streaming gateways to the ETH0 or F0 interface of the workspaces or AppStream 2.0, which is located in an AWS managed network. The contact center agent is now connected and viewing the ETH1 or ETH1 interface, which is located in the customer managed VPC. The customer managed VPC can have other application resources and connectivity to the internet or back to on-premises resources through a VPN. The resources in this VPC can be controlled with customer managed security groups, which allow administrators to configure security controls and reduce attack vectors by implementing a stateful firewall. The general best practice of installing contact center software components in a virtualized environment, including installing the contact center software agent on, in this case, the WorkSpaces AppStream 2.0 instances, and installing the softphone component on the agent's physical device. This allows for the call controls and software to run their virtualized instances, but offload the media traffic, audio and video, on the local endpoint and route that traffic directly to the contact center application resources in the cloud or on premises. This has been a standard to reduce latency and improve call quality. Now, I would like to discuss an alternative architecture in this scenario. Notice the softphone client has now moved from residing on the physical endpoint of the end user to residing within the workspace or AppStream 2.0 instance. The media traffic is now encapsulated in the streaming protocol, and the media and call controls now reside and come from the virtual instance sending the traffic to the contact center resources. This scenario has not always been supported by the contact center vendors. However, with ample testing and the ability to place resources closer to workspaces or AppStream 2.0 instances, customers such as Maximus have found success deploying it in this scenario. Customers also utilize this architecture to increase flexibility when a vendor does not offer a solution to offload the agent media, or if the agent endpoints are not compatible for the softphone client, like Zero clients, for example. It is recommended to check with your vendor and review your contact center vendor's documentation and best practices on deploying in a virtualized environment prior to implementation. Before we move on to Q&A, let's recap today's session. We reviewed key business challenges encountered by contact center customers, come to an understanding on how Amazon end-user computing addresses the needs of contact centers, learned how other customers use AWS EUC services for their contact center deployment, and we dove deep into best practices for contact center agent deployments. As next steps, I would recommend you check out the resources below to learn more. If you are ready to get started with a deeper dive or set up a proof of concept, please reach out to your account representative or contact AWS, and we would be more than happy to help discover next steps. At this time, we have concluded the speaking portion of today's sessions, and I would like to thank you for joining this session today.